All right, this is a video over the examples in 2.1 that we did, or 2.2 that we didn't get to in class, going over the 3x3 systems and making sure that we're good on all of those. So let's look at number 2. This one has 3x plus 7y minus 8z equals 5, x plus 3z equals negative 2, and 4x minus 3y equals 7. So you need to determine, first of all, how you're going to go about getting this down to two variables. And you just can either go with since two of the equations only have two variables, usually when that happens, I let one of those be an equation kind of all by itself, and I try to make the other pair look similar. In other words, have the same variables. So I like that this x has a 1 in front of it. So I think I'm going to use that to help me clear out a different equation. So I'm going to try to maybe get rid of the z here so that this can have both x and y as well. And so our goal is we're getting rid of the letter z, hopefully here, and then we're going to have this one over here that already has an x and a y. So I'm choosing to cancel z. So then I'm going to multiply the top equation by positive 8 to make this 24, because 3 and 8 both go into 24. And I'm going to multiply the bottom equation by a 3. So then the top equation would become 8x plus 24z equals negative 16. The bottom equation would become 9x plus 21y minus 24z equals 15. I would add my columns together, like terms. So this is going to be 17x plus 21y. The z's are going to cancel out, and then that would be negative 1. So then once you get down to x and y only for both equations, for this one and for this one we just did, you'll want to take those two together and treat this like a regular two-variable system. And it looks like to me it'd be easier to cancel out the y's here. So I'm going to multiply everything in the bottom equation by a 7. Now let's see what that gives us. That would be a 28x minus a 21y equals 49. And then my other equation was 17x plus 21y equals negative 1. If we add the columns, the y's cancel out. That would be 45x equals 48. Divide both sides by 45. And those are both divisible by 3. So if we do that, that would be 16 over 15. So my x part is going to be 16 over 15. I still need to find my y and my z. So the first thing you do is you back substitute this answer into either this one or this one, either one of the equations that has the x and the y. I'm going to use the 4x minus 3y equals 7. You could just as easily use the other one. So this is 4 times 16 over 15 minus 3y equals 7. 4 times 16 is 64 over 15 minus 3y equals 7. I'm going to subtract over the 64 over 15, getting a common denominator over here. I have to multiply 7 by 15, so let's pull up a calculator because I don't know that off the top of my head. So 7 times 15. 7 times 15 is 105, so this is going to be 105 over 15 if we get the common denominator. And 105 minus 64 is 41. So this is negative 3y equals 41 over 15. And we would need to multiply both sides by negative 1/3 to get rid of that negative 3 there. So this tells me that y is negative 41 over 45. Okay, And I need to find z. It might be easier to plug z into that x plus 3z equals negative 2. So x is 16 over 15 plus 3z equals negative 2. That would be 3z equals, I'm going to go ahead and make this a common denominator. That would be negative 30 over 15 minus 16 over 15, or negative 46 over 15, and we multiply both sides by 1/3. So that's negative 46 over 45. So notice they don't always have to come out to nice answers, but you definitely can still find x, y, and z if there is a solution to be found. So then we're going to look at another one. So this is already got a y and a z isolated on this first one, so I'm going to leave that alone. And I'm going to try to cancel out the x on the other one so that we can get that to have just y and z as well. So if I'm going to cancel out x, and I'm choosing to do that so that this will be something that will help us go forward, I'm going to multiply the top one by a 5 and the bottom one by a negative 3. So this would be 15x plus 30y minus 60z equals negative 15. And then negative 15x plus 6y minus 6z equals 21. Adding our like columns, this would be 36y minus 66z equals, I believe, positive 6. And then we'll stack those two on top of each other. So 2y plus 3z equals 7 over 36y minus 66z equals 6. You could choose to multiply by whatever you want, but I'm going to cancel out the y. So I'm going to multiply that top equation by actually a 22, because 22 times 3 would be 66, and that would make that cancel with that. So this is going to be 44y plus 66z equals 22 times 7, which we'll do real quick. 22 times 7 is 154. So then we are going to get 80y equals 160. Divide by 80. That's going to be y equals 2. So that one came out nice. So 2 times 2 plus 3z equals 7. I'm going to go ahead and I'm going to use this one and find the z. So that's 4 plus 3z equals 7. 3z equals 3. So z equals 1. And then I'm going to find x by plugging in the y and the z. So 3x plus 6 times 2 minus 12 times 1 equals negative 3. That's 3x plus 12 minus 12 equals negative 3, or 3x, that cancels out, equals negative 3, so x equals negative 1. So this one comes out much nicer. It's negative 1, 2, and then 1. You make sure you put x, y, z in the correct order. Now you can always check yourself. This would be 4 plus 3, which is 7. Negative 3 plus 12 minus 12 is just going to be a negative 3. And then negative 5 minus 4 is negative 9. Plus 2 would be negative 7. So all of those work out and the solution is good. All right, for these next couple problems, we're going to be setting up some word problem analysis here, reading the problem and then writing what we think the system is. So for number 5, it says the annual return on Sid Carrington's 3 investments amounted to $21,600. Annual returns means that we're looking at simple interest, which is I equals PRT, for principal times rate times time. He had 6% on a savings account, 8% on a mutual fund, and 12% on bonds. The amount of Sid's investment in bonds was twice the amount of his investments in savings accounts, and the interest earned from his investment in bonds was equal to the dividends he received from his investments in mutual funds. Find how much money he placed in each type of account. We're going to be doing a lot more with word problems later, so I'm actually just going to let's just do a setup on this one. So if we're looking at his 3 different accounts, we need to give them names. So we're going to call X the amount in his savings. We'll say that Y is the amount in the mutual fund. and that we're going to let Z be the amount in the bond or bonds. Okay, so the amount of his investments in bonds was twice the amount his investment in savings. So bonds, which is Z, is equal to twice savings, which is X. So that right there is one equation by itself. It's a relationship between bonds and savings. The interest he earned on his investments in bonds was equal to the dividends on his mutual funds. So those are both interest things. So we need to talk about the interest that he's earned. The savings was at 6%, so that would be 0.06x times 1 year. So this is 0.06 is the rate, x is the amount, and t is standing for 1 year since t is annual. So that's a single year. So his interest in savings is 0.06. His interest in mutual funds is 0.08. And his interest in the bonds is 0.12Z, so 12%. So this is saying his interest earned from his investments in bonds was equal to the dividends, which is also interest from mutual funds. So his interest in bonds, 0.12Z, equals his interest in the mutual funds, which is 0.08Y. Now the only thing we're missing is we haven't used this 21,600. That's how much all three investments added up to for the year. So that's adding all of these interests together. So 0.06x plus 0.08y plus 0.12z equals 21,600. Now, if I was going to solve this, which I didn't ask you to because we're going to do that later in a different section, I would probably first of all just substitute in this, that 0.12z and 0.08y are exactly the same. And since this equation is also in x and z, I would just replace this 0.08y with a 0.12z and then go from there, because then you eventually would have that. That's using substitution. You would be able to just solve you have equations in x and z, and you could solve for one of them and then go from there. So let's look at number 6, because this one's a 2-variable one and we actually are going to solve this one. So it says the total number of passengers riding in a certain city bus in the morning shift is 1,000. So if the child's fare is 50 cents and the adult fare is $1.50 and the total revenue from the fares in the morning shift is 1,300, how many children and how many adults rode the bus? So we have two different types of people. X is going to be the number of kids on the bus, and Y is going to be the number of adults. So since we know 1,000 people were on that bus, that's X plus Y equals 1,000. The prices have to do with each one of them too. Every child had to pay 50 cents. Every adult had to pay $1.50, and they collected $1,300 in money. So if we wanted to do either elimination or substitution, you could do either one. I'm actually going to multiply this top equation by negative 0.50 to make this X cancel out. So this would be negative 0.50x, negative 0.50y, and that would be negative 500. So we bring down the other equation, and this would cancel those out. That would just be 1y, and this would be 800. So that tells me that we had 800 adults riding, since this is already 1. And then that means since there's 1,000 people, there would be 200 children. All right, and that's the end of that section.